In this video, we are going to classify critical numbers as local max, local min, or neither. Okay, and so this is the function that we are looking at, this polynomial f of x equals minus 8/3 x cubed minus 55 halves x squared plus 7x minus 8. If you haven't watched the previous video where we solved with this same function, we found where the intervals on which this function was increasing and the intervals on which this function is decreasing, you need to go back and watch that video, because most of the work for this problem, right, classifying the critical numbers, was done in the previous video. Okay, so go back and watch that one and then come back here. All right, so having gone through all that work for increasing and decreasing, we have found that there are two critical numbers, -7 and +1/8, right? And we have our sign diagram, so all we have to really do is look at our sign diagram, and we'll be able to tell if this is a local max, local min, or neither on this. So remember, the key is here we have the sign diagram for the derivative, and when the derivative is negative, like it is here, the original function is decreasing, right? Meaning that it is going down as it goes from left to right. So the original function was doing something like this, okay? And it doesn't have to be exact, just so you can get the idea of it. All right. And then to the right of -7, it was increasing. So the function was going back up again, like so. Okay. So that means that you have a local low point right here if it's decreasing and then increasing. So that means that there is a local min at -7. Okay, so that one is classified. Next up is the other critical number, +1/8. Right, we already know that to the left of 1/8, the function was increasing, was going up, right, as we go from left to right. And then over here, if we look at the sign diagram, the derivative was negative. What that means is that the original function was decreasing, right? So that means that the original function was doing something like this, right? It was going down as you go from left to right. And so what that's going to form is a local high point up there, right? And that means that there is a local max at 1/8, okay? All right, so we have classified the critical numbers as being a local max, local min, or neither. Remember, these are only the x values, okay? So if you're working a problem and they ask, this problem can be asked in a different way. If they say, what are the local min values, right? Then what you would need to do is to take these numbers, -7 and +1/8, and plug them back into the original function to get the y value of the point on the graph, the y value of where that high point is and the y value of where the low point is. We didn't ask that here. We're just asking you to classify this as one of these three, right? But if you're looking at this problem to try and your problem asks for the values, local max values, local min values, remember they want the y values, so take these numbers and plug them back into the original to get those local max values, local min values.